Welcome back, guys. Over the next couple of lessons we are going to be learning how to make this little space asteroid avoid space shooter type game that I've got going on here, and we're going to start off with the basics, and then we're going to be adding more and more into it every kind of week until we end up having something quite cool like this, and we'll eventually have some sound and stuff like that in it as well. So let's get cracking. I've got my spaceship.png and asteroid.png. These files will be linked in the GitHub as well, so you can grab those from here. What's important about these is to make sure that if you want to use your own ones, make sure they're PNGs, because they've got the obviously the white backgrounds on them, so like the transparent backgrounds, so like this one here. So that's really important, because obviously you don't want your spaceship to obviously have a big white square around it, so make sure it's a PNG with a transparent background. If you can't find one, just download the ones that we've got on the GitHub. Or equally important, you've got to make sure that our Python file is saved in the same place as these two. Okay, so I'm going to save it all on my desktop, but you should probably make sure you save it in a file somewhere, and then obviously everything's in the same folder. Sorry, save it in the same folder. Yeah. So there we go, Asteroid Avoid, and my two sprites that I'm going to be using. Okay, so this is again going to be in Pygame, so I need to import Pygame, and I'm going to just do import pygame.locals. So from pygame.locals, I'm going to import all, and that just means that when I start referencing Pygame, the functions that Pygame uses, I want it to write out loads. I'll just be able to write a shorthand version of it. I'll show you an example in a bit. And also I'm going to import random, because I want my asteroids to be spawning at random positions. So I do pygame.init to initialize Pygame, and now I'm going to start off by actually coding the window and kind of all like the kind of basic stuff to get us started. So we're going to set ourselves an FPS, and we'll set this down to 30, but obviously if we increase this, it's going to increase the speed of everything, so you can set it to 60 FPS, and that'll increase everything by, like, make everything move twice as fast. We have a variable here called frames per sec, and it is going to equal pygame.time.clock. Now what this is it's just our clock that we can put in a minute when we actually use this. We're going to feed it that FPS argument, and this will actually make sure that we tick at the correct amount of frames per second. So if we put if we change this to 60 and then we put FPS in here, it's going to make sure it ticks at 60 frames per second or 30 frames per second. You know, it's just going to make sure we tick at the correct amount of frames per second. Okay, so we set up a clock there, and then we'll set up the tick for it in a bit when we get into the loop, and I'll show you how that works. And then from here we need to, we could actually do a couple of colours and things like that. I'm actually going to have my display actually start off as black, so I'm going to just do it like this while we're not got a background and things like that. I'm going to have it as black because, you know, night sky and that kind of stuff. And then I'm going to get a window. So I'm going to code my window, and it's going to be equal to pygame dot display dot set underscore mode, and then in brackets it accepts two arguments here. It accepts a width and a height, like that. So basically the reason we do this is so that things like this we can just reference them as pygame.display. If we didn't do that, there would be like another bit that goes in front of it every single time, so we don't want to be doing that. So we can just, that's why we do this part here. Okay, so pygame.display.set mode, and then we've got our size. I said 500 by 600, didn't I? Yeah, we want it kind of long, we don't want it square. So this is the width, and this one is the height of it. So that's our window set up there. Now what I'm going to do is I'm going to take that window, and I'm going to fill it with the colour. So my black, which I've just defined here. So these are RGB values, remember. If I set this to 255, that's R, so that's red. So that would be 255 points of red and 0 anything else. So that would then change this to red. Okay. So 0, 0, 0 means there's nothing in there, so that is going to be black there. So I'm going to fill the window with black, and then I'm going to just give a caption at the top. So this point here at the top here, and my game is going to be called Asteroid Avoid. So Pygame dot display dot set caption, and then I just pass it a string. So you can call your game whatever you want. I like Asteroid Avoid. Nice bit of alliteration there. So yeah, we're going to just put that in the top bit. So that is our window all sorted out from there. Now, what we're going to do is we're actually going to grab the width and height. So this width and height here, there's a couple of ways we could do this. I'll show you this way to do it because actually it's quite handy to know how to be able to get these values if we need them. Okay, so what I'm going to do is I'm going to create two variables, one called screen width and one called screen height. And what I'm going to do with these two variables, they're going to equal Pygame dot display dot get surface, get underscore surface, and then get underscore size. So what will happen with this is that when this gets the size, it will return a width and a height. So it's going to return 500 and 600, and it's going to then save those into here and into here. So, you know, we know the size of the screen here, but it's useful to kind of know of a function like this in case we are dealing with screen size which maybe is different, is changed, is set by something else, so that we can quickly return the width and the height. And we've got these two variables here. These will come in handy in a bit when we're actually looking at collisions and what happens when a asteroid passes past the bottom of the screen and things like that. So we could actually have the user set the screen size and things like that if we wanted to, and then using this function we could just return whatever they set, and then we could pass these arguments in to keep track of our asteroids. Okay, so that's all that does. That just gets our width and height, and obviously you don't need to do this. You could just put 500 and 600 in for the width and height if you want, but we're going to do it this way so you know how you can get the width and height of any window that you create. So now we're going to go on to actually making the classes. So I actually have two classes, which is just an enemy and a player. So we're going to grab our enemy class, and they are going to use the pygame.sprite.sprite class. Okay, so I'm just going to do a couple of bits here, and then I'm going to explain what it is I've done. Okay, so a little bit of slightly more advanced here, but this is probably only the three weirdest things you're going to see that you might not be able to understand on this go around, but the more you use them, the more it'll become apparent. So Pygame actually has a lot of classes built into it. So a class is kind of like a blueprint for an object with things like lots of attributes and things like that we can use. So like this sprite class contains collisions, it contains rectangles, it contains shapes, it contains a lot of different things that we can use instead of having to reprogram everything ourselves. So basically I want my enemy to be able to have some of that pre-written code. So what I do is I inherit that sprite class. Now in order to use it, I need these two lines of code underneath it. Now it's really important to make sure that you get this right. So there is a space between here, and there are two underscores on this side of the init, and there are two underscores on this side of the init. And then when we return, super should be indented, and then it's dot, and then two underscores, the init, two underscores, and then bracket, bracket. So basically what I'm saying is, I want to use all of this sprite's code, all the attributes, all the cool stuff that's already been coded. And then what I do here is I actually inherit all of that stuff. So my enemy now can use all of that stuff without me having to go round and round and recode it all. And we'll see that working in a second when I actually code some of this stuff. So How to make a class. So my enemy class, I need to obviously give it a few different attributes. So the first thing it's going to need is an image. So I'm going to code it as self.image. So in Python we have to actually code all of our attributes with self dot at the beginning to say that these are attributes of the enemy. So you're going to be writing self dot quite a lot. So self.image, and that image is going to equal Pygame dot image dot load. And then provided our asteroid is in the correct place, load is what we want, providing that asteroid is in the correct place, so here it is saved, and we're going to load that asteroid in. So we're loading that asteroid in there, so make sure you spell it correctly. It's going to be spelled exactly the same capitalization, everything exactly the same. So that is going to load in my asteroid there. Now, the next two things are if we think about this image, when it is created on the screen, we're going to basically reserve it a rectangle. Okay, so we're going to make a rectangle for it, and then we're going to take that image and we're going to place it on the coordinates of that rectangle. Okay, so we're actually going to do two things here. We're going to create a surface for it, and that surface is going to be, let's go 50-50. Okay, so what I've said here is I'm going to create a rectangle to place this asteroid on. It's going to be 50 by 50 pixels. So that will be the hitbox of this asteroid. So this asteroid is actually slightly bigger than that. Actually, I'm going to make it slightly smaller than that, because I seem to remember 50 and 50 being slightly too big. So I'm going to make it slightly smaller than that. And what I'm basically doing here is the hitbox is going to be within the asteroid here. There'll be a little bit around the edges, which when we hit our spaceship we won't actually trigger, but the main bulk, the main inner part of the asteroid, when we hit that, we're going to actually cause the game to stop. Okay, so this surface here creates well, it doesn't create the rectangle for us. It is the starting point for creating the rectangle. Okay, so I'm saying here I want a surface of 40 by 40. Now this next bit is where I create the rectangle. So this rectangle here, let me create it first and I'll explain it. So self.surf.getRect. I do like that one. It means get rectangle. And then we pass it this, and I'll just explain what this is in a second. So, okay, so this rectangle here, so these two things basically work together, okay? They are going to work together to create a hitbox for our asteroid, okay? First thing we're going to do, we create the size of the hitbox. So we say we want a hitbox which is going to be 40 by 40. Once we've done that, we then use those attributes, that 40 by 40, to create a rectangle. And it's this rectangle that we're going to create which will actually check if we've collided. So when we look at our collisions in a bit, we're going to look at this rectangle and we're going to see if it's collided. So I create the size of the rectangle here with .surf, which creates the size of our rectangle. Then underneath it, I actually create a rectangle. So that's what this bit here does, this self.surf.getRect. I create a rectangle of the size .surf. So I create this rectangle is of the size of this attribute, self.surf, which is here, and we know that that is worth 40 and 40. So we're saying create a rectangle using this size, and then this is a position. So I'm saying the center of that rectangle needs to be between, so across the screen will be between 440 and 460. So the width of my screen is 500, so it'll start at 40 and go up to 460, so it's never going to spawn like half on the screen basically. And 0, so 0 is the top of the screen. So these are coordinates. So I'm saying, obviously we don't want our asteroid always spawning in exactly the same space across. So we want, when we're spawning, for that across axis, we're actually going to choose a random starting position across. Obviously though, we do want it always to spawn at the top of the screen, so we're going to pass it that 0, okay? So we're going to say the center of our asteroid needs to start at a random position across, but always at the top of the screen. Okay, and those are our attributes from there. So we've got 2 more functions to do for our enemy from here. We've actually done our attributes, so we now need to look at actually getting our enemy to move. So enemy.move, it doesn't need anything in there apart from self. And we are going to, every second, we're going to move the rectangle. So this rectangle, basically, my image will trace the path of this rectangle. So we're going to move the rectangle, and the image will follow that rectangle. Okay. So every frame, what we want to do is we want to move that rectangle, move, and we've got this cool little move in place, and we want to move it down the screen. So I'm going to give it these coordinates, 0, 10. Now, what this does is it takes our rectangle where it is, and then this 10 here is the height, so this is the up and down, and I'm going to add 10 to it. So by adding 10 to it, so if I start at the top, which is 0, and the bottom is 600, I'm going to keep adding 10 to it until I get to 600, which will mean I get to the bottom. So that's what this means. It takes wherever my rectangle is at the moment, we're going to add 10 to its up and down, so that we keep going down the screen until we get to the bottom. Okay. Now, if we do get to the bottom, we need a little bit of a condition here. So we're going to do if self.rect.bottom is greater than 600. So if my rectangle ever makes it to the bottom of the screen, so my rectangle, the value of the dot bottom of my rectangle, so this will return a value which shows me where the bottom of that rectangle is. If that is ever greater than 600, it means I've gone down to the bottom of my screen. And if that happens, I want to return to the top of it. So I can do that by actually doing self.rect.center. So I'm going to reset the center of my, so basically here I'm resetting all the coordinates of my rectangle, and again I'm going to choose a random integer to start, so random across, so random.randint, and again between 30 and 460. And then I'm going to give it a position of 0 like that. So this will spawn my asteroid at a random position, so the center point is randomly across the top, but it will basically, if my asteroid reaches the bottom, it will just push it back up to the top in a new random position to come down now. Okay, so we've got our movement loop going round and round there. And that's all we do for our movement. Our movement's done for the time being. We'll check back on that later to actually make it a bit more interesting, but at the moment that's all we need to do for it. The last thing we're going to do is we're going to do a draw function. So the draw function just takes one argument, which is surface. So you can see actually all of my functions take a self. That's just something Python does. You have to always pass it self to begin with. But you know, when we actually call this function, we actually need to put anything in the brackets, and I'll show you that in a second. But this one here, because we've got surface, we're going to have to tell this function where we want it to draw. So we obviously want it to draw on the window that we've created. So we'll pass that in it once we actually use this function in a bit. So our draw function is going to look like this. We're going to do surface.blit, and it's going to be the image we want at the position of self.rect. So let me just explain how this works here. So whatever surface we pass it here, we're going to draw it. So .blit kind of in layman's terms just means draw, okay? So whatever image I pass you, draw onto this window, okay? And then I pass it two arguments. I pass it the image, so self.image, so that is this here, my asteroid.png, and I pass it some coordinates, self.rect. So I'm saying draw this image at the coordinates of the rectangle. So obviously we've spent a lot of time sorting out where the rectangle is going to go. So every single loop, every single time we draw that asteroid, we're going to draw it on top of that rectangle. Okay, and as the rectangle moves here, so we're moving that rectangle, we will continually draw that asteroid on top of that rectangle so that it looks like the asteroid's moving, or the asteroid will be moving, and the rectangle will be moving. So next class rather, not function. Next class is going to be our player class. So we're going to do class and we're going to do player. And we set them out like our enemy as well. And then we want to do the same two first lines, so these two lines here, because it's going to be exactly the same sort of thing, because things like, you know, I'm inheriting bits from the Pygame sprite that I want to be able to use, things like surface, a number of things like image, like I'm inheriting stuff which I'm going to be using, okay? So I'm just doing that bit again there, and now what I need to do is I need to give my player some attributes as well. So they are going to have the same three attributes. We're going to just make them slightly different. So they need an image, and the image they need, I've got spaceship.png. So making sure that it is spelt exactly as it is there. They need a surface area as well. So we're going to start with 100 by 150, but we'll end up tweaking this when we get into collisions and hitboxes and things like that as the game gets a little bit harder later on down the line. So we'll start it at 100 and 150. And then we need its rectangle. So we are again going to get the get the rectangle. So from the size of the rectangle from the surface. So if you remember, surface is going to tell us the size of the rectangle, and then we're going to use getRect to actually create a rectangle of that size in these positions. So we want this spaceship to be in the middle bottom of the screen. Okay, so we know the middle of the screen. So if the width of the screen is 500, we know the middle of the screen is going to be 250. Now we know the bottom of the screen is 600, but this is where the center point will be. So if you imagine like a rectangle and the center point in the rectangle, if I put 600, it's going to put that center point right at the bottom of the screen. So it means that I'm going to miss half of my image. So I need to do a little bit of kind of like maybe trial and error, maybe a little bit of maths. I did it with a little bit of trial and error, I think, more so than the maths. So I kind of looked at it, and when I was drawing it, about 525 felt about right to actually draw it as like on my up and down kind of thing, you know. So 250 across, then 525 pixels down for that center point, and then that should be enough so that we can still see the rocket from there. Now we've got a draw function as well, and the draw function is exactly the same as this. So I can take it exactly as it is, and I can just put it in here. And really, we will actually change this code to make it more efficient, so we don't have two draw functions which are exactly the same. We're going to sort of build something up which will handle that stuff for us, okay? But for the time being, we've got that draw function there. Now the next function we need, the last function for the player we are going to need, is something which handles the left and right keys. So obviously, we need to be able to move our spaceship, or else this game is going to be pretty poor. So we need to actually create a function, a function within the player class to actually look at the keys which are being pressed, and then to move the rectangle based on the keys that are being pressed. So I'm going to call it. We'll call it update, because we're going to be updating the position based on these keys. Again, this is going to be something which changes later on. And we are going to do pressed keys equals Pygame dot key dot get underscore pressed. Okay, so what this does, this function here, obviously you probably have guessed it already, this listens to what is happening and it actually returns any keys that are pressed as a list into here. Now, if what I'm going to do now is we're going to look in this list that gets returned, each loop, and we're going to see if the left or the right keys are being pressed. If the left or the right keys are being pressed, we're going to move self.rect into a new position from there. So what we want to do from here, so there's actually one other thing to do as well before we go further. So because we don't want our rectangle to be going off the side of the screen, the side of the screen, the left-hand side of the screen, this is 0. So we can only move our character to the left if their position is already greater than 0. So basically, if my left position is at, sorry, that should be self.rect.left. If that left position is already at 0, it means I'm already on this left-hand side. So I don't want to keep on going left because I'm just going to disappear off the screen and then the game is no good, basically. So if my self.rect.left is greater than 0, so it means I'm still on the screen on this left-hand side, then I can go left. But obviously, if I'm at 0 or I'm less than 0, it basically means that I shouldn't be able to go left anymore. So I hope that kind of makes sense. It all makes sense when we actually see the game going. So providing I'm still on the screen, so provided that left coordinate is still greater than 0, to see that I'm still, the left-hand part of my rectangle is still on the screen, I'm going to check to see if the left key has been pressed. So if pressed keys, and then we look for K left. And if that happens, we are going to move our rectangle, so self.rect.move underscore in place, and we're going to move our rectangle -5 and 0. Okay, so this will move our rectangle left. And then we're going to do basically exactly the same sort of thing for the right-hand side. So I'm going to do it again. So if self.rect.right, and this time is less than my screen width. So I could just put 600 in here, or as I returned the screen width earlier, let's use that. Okay, so if it's less than the screen width, so as long as it's less than the screen width, I'll be able to go right. Okay, so obviously the screen width will return the width of the screen, which is 600, so that'll be this point right over here. And if I'm less than 600, the right-hand side of my rectangle, if that position is less than 600, it means I can still go right. Okay, so what we want to do from now is we're going to do the same again. So we're going to do if pressed keys, but this time we're going to do if pressed keys, and we're going to do K underscore right this time. And what we want to do is we want to move this a +5 instead. Okay, so this will be how we update our left and right. And that's it. Those are our 2 classes done and dusted. So what we need to do now is we need to make the objects, and we then need to actually put this all into a main loop. So I'm going to make my 2 objects. So I'm going to make myself a player. So P1 is going to equal player, and then E1 is going to equal enemy. Now what's nice about this, obviously, is I've made these as classes. It means that I can actually come back at any time. If I want to make a second enemy, I can do E2 equals enemy, and so on from this, okay? And you can have a play around with making more players and enemies and things like that, but we are going to expand this, and we are going to make more enemies as we actually expand the rest of the code. So from here now, we're going to make our fairly short, actually, main game loop. So we're going to say while this is true. So basically this loop will continue going until we exit the game, kind of thing. So we're going to say while true here. And what I'm going to do first of all is I'm going to add another kind of like listening type event. So like here where I'm listening to the keys being pressed, I'm also going to listen to make sure that this red X hasn't been pressed. It's important to do this because if you don't do this, then there's no way to exit the game, and then you'll just crash out and there'll be loads of errors and stuff like that. And stuff like that. So I'm going to do for event in Pygame.getEvent. pygame.event.get, like this. So what this does, pygame.event.get returns a list of everything that's happening at the moment. So all of the mouse movements, the coordinates of the mouse movements, the buttons that are being clicked and things like that. It actually listens the whole time to what's happening, and say if you click the button, it will return that into this event variable here. So while I'm looking, at this, if the event.type is equal to quit, that means I'm going to quit the game. So I'm going to do pygame.quit. Okay, so just like that. So basically this listens and returns a list of the events that are happening. If any of those event types are the same as quit, so basically if I click on the X, that is an event type which is the same as quit, I'm going to quit Pygame. Okay, and that's going to stop the whole thing from running from there. And we will update that a little bit later when we actually start making it better to kind of get it to exit a little bit neater. From here, what we're going to do is we are going to call our player1.update function, and then we're going to call our enemy1.move. Now, did our move take I don't think it did take. That shouldn't take any arguments. We'll see how this goes. We might have to change that and add an argument in, but I don't believe it does. So players update, they move, and then what I do is I take my window and I fill it with black. Fill, and I fill it with black. And then I draw both of them. So E1, let's do P1.draw, and then E1.draw. And then once I've done that, and obviously I need to say where I'm drawing them to, so I need to draw them both to the window. And then once I've done that, I am going to update the display, so pygame.display.update, and then I'm going to tick my frames per second. So my frames per second, where did I put it? Here, frames per second. So that's equal to the clock at the moment, so that's actually a clock. What I want to do is I'm basically saying here, that frames per second, I want it to tick at the FPS that I gave you. So at the top of the screen, I set FPS to 30, and I'm saying here, make sure that clock ticks at 30 frames per second, so that this loop happens 30 frames per second, okay? And if we've done it all right, fingers crossed here, because I didn't run this as we was going through, we should have a game. So there we go, there's our asteroid, there's our rocket, and we're going to move it away from each other. So at the moment, there's no collision detection or anything like that. But we're going to add those little bits and pieces into it and a scrolling background over the next couple of lessons. So I hope you enjoyed that. I hope that you got a little bit out of that. And make sure you come back next week, because we're going to be adding in, like I say, the next couple of bits to it. So actually doing the collisions, score, and making it better and better and better, okay? So get your head around that to start, and then I'll catch up with you guys next time.